Hi, in today's lesson, we need to try and work out how big the Earth is. We're going to leave uh, the piece of work on the rare Earth until we're back in school. So today, I want us to work on uh, pages 4 and 5 of your Theme 2 booklet. Okay, we've already seen how big the Earth is in comparison to the other planets in the solar system. This diagram um, gives us some indication of the relative size, but um, have a watch of the video clip just to put things really into perspective. But today's lesson isn't really about a comparison. It's about how we can actually work out how big our own planet is and how it was actually done right at the start. Now, people have known that the Earth is roughly a sphere for thousands of years. The idea that everyone thought the Earth was flat until Christopher Columbus set off sailing is nonsense. Perhaps what's even more staggering is there are some even people today who seem to think that the Earth we live on is flat, despite all of the evidence. But the way that it was first worked out, just how big this roughly spherical Earth is, goes back to ancient Egypt. A librarian in Alexandria called Eratosthenes, about 2,300 years ago, actually worked this out. And he did it by making an observation of a stick in the ground. Because he noticed that where he worked in Alexandria, if it had a stick in the ground at midday, it cast a bit of a shadow. Nearly 800 kilometres south of that, in a place called Aswan, similar stick at noon, hardly cast a shadow at all. And he was able to work out, using a bit of simple maths, roughly how big the Earth was. Now, I'd like you to do the same. So, we're going to assume the Earth is a circle. It's not quite, it's almost. And it's actually a bit fatter around the equator than it is around the poles, but that's fine. We'll go with it as a circle. It's a reasonable assumption. And what we need to do is we need to work out um, if we know the length between these two sticks stuck in the ground and the angle made by the shadow that was cast, how big the Earth was. I like to call this idea Eratosthenes' pizza. So I'd like you to have a go at working this out. Watch the video on Eratosthenes' pizza to help you out understanding the maths. But we need to work out what the circumference of the Earth is. So press pause now, watch the pizza video, and try and work out what the circumference of the Earth is. Remember, we want it to 3 significant figures. Okay? Have a go at that now. Okay then, let's see what you've come up with. So, we know that the distance from Alexandria to Aswan is 791 kilometres. And we know that this angle cast by the shadow is 7.1 degrees. Now that 7.1 degrees gives us, if you like, a slice of the Earth, like a slice of the pizza. So if I take a full circle and divide it by 7.1, what we end up with is 50.7 sectors. That's the maths name for a pizza slice. There's 50.7 of these sectors of the Earth. represented this by this distance from Alexandria to Aswan. Now, if we know there are 50.7 slices, and we know the edge of each of those slices is 791 kilometres, if we multiply the two together, we get just over 40,000 kilometres. So to three significant figures, the circumference of the Earth is about 40,100 kilometres. Okay. Having worked that out, we can now start to work out a few more features of the Earth from that circumference. We can now work out the radius of the Earth. Having worked out the radius of the Earth, we can then work out the volume of the Earth. And once we've got the volume, we can then work out how heavy the Earth is, because we do know its density. On page 5 of your booklet, you'll find a series of calculations that you can work your way through. All the formula are there, okay? So I'd like you to give that a go. We're going to talk through the answers when I see you in a live lesson next week. So, as we watch the sunset at Alexandria in Egypt, we can see that actually a fairly simple calculation on the back of a fairly simple observation allows us from first principles to work out how big our planet is. It's the first step in really starting to understand this lump of rock that we live on. We need to explore it more, and particularly we need to look at what's below the Earth's surface, but that's for another lesson. I'll see you then.